Morning, everyone. I don't know if you can get me.
Yes, we can get it.
I don't know where are your friends? Like, I was supposed to start. It's already 9 hours. Yeah, so we'll wait until 9:10 we start. Yeah, 9:10 we start. I don't know how many are you, like those who are under PESA, BCG, ENSA, MIP, and SVT.
The number I don't know exactly, but we just do together. Yeah.
Okay, then we'll wait until 9:10. Then 9:10 will start.
All right.
So it's 9:10. So yeah, so we're going to start, and those who are coming, they will join us. They will join us. Yeah. So for those who don't know me, my name's Jacob Banda. Yeah, I'm doing BCG, FST in FESI, and I'm in my first year. Yeah. So we're going to start with Atomistique, and I'm supposed to teach you guys for 3 weeks. Yeah, we're supposed to be done with everything 3 weeks, which is particularly to me something uh, which is a challenging in such a way that you usually do this topic in we usually do this topic in 3 months. Yeah, 3 months, and you even write exams. That's what, when you go to universities, it's a topic on its own. So, but I'll try summarizing it, and I'll try by all possible means to explain it very well to you, and so that you must get some ideas, and when you go to your universities, different universities, you have you won't have any difficulties, yeah, in terms of Atomistique. I hope you can get me.
Yes, we can.
Yeah, so we won't have any difficulties. Actually, chemistry, like when you go to universities, chemistry, I can say for me particularly, like most of Zambians, they do well. Yeah, most of Zambians, they do well chemistry if you have where to start from. Yeah, so I want, when you go to your different universities, the lowest at least must get a 17 out of 20 among you guys. So yeah, so that's all. So all I need is your cooperation and your positive, like you must be positive. Don't think that the things are hard. Nothing is hard here in Morocco. It's just how you take things and how you behave yourself. And you should also know your purpose, know your goal, know why you are here, and also build your life in every aspect, like every aspect, social, be it socially, be it spiritually, mentally. Build your life. Here's where you start your life, and it will determine who you become in future. Yeah. So with all that, we're going to start with our lesson for today. And our lesson for today, by the end of this lesson, you should be able to know what is atomistic and structure, what is atomistique and the structure atomique. You should also know what is structure électronique des atomes, theories classique and ondulatoire. You should also know the classification periodic des éléments. You should also know liaison chimique. So for today, we'll do atomistique and structure atomistique. So yeah, that's what we basically look at today. And also, if we have time, we also look at the structure électronique des atomes on theory classique. Yeah, because ondulatoire is also another topic on its own. So atomistique and structure atomic, these are things which you already did in secondary. It's only, we're going to talk about an atom. You did an atom and you know what an atom is. So we're going to start with, can you see my sharing? Can everyone see my sharing?
Yeah.
Yes.
So we're going to start with atomistique and the structure atomic. So when for atomistique and structure atomic, we're going to start with atoms and elements. We know that les matières est formée à partir de grains élémentaires. So we know that matter is formed from elementary grains. When I say elementary grains, it's something simple which you already know. Is the protons, the electrons and the neutrons. That's the grains elemental. It's also the same as, so you see, as we go this lesson, you see grains elemental and particular elemental. Those are just the same things. They just means protons, electrons, and neutrons. So we see matter is made up of these things. And these things, when they are combined together, they make up an atom. So basically, matter is made up of atoms. So when we continue, it says, les atomes qui diffèrent par layer structure and layer masses. We know that we have got different atoms. Carbon, we can give an example. Carbon is different from helium in terms of mass and in terms of structure, and these other atoms. And we have got 109 species of atoms which are known, and these species, like you can also say others, they say elements, 109 elements, which you know already. Yeah. So chaque élément est désigné par une abréviation, so symbol chemique. So we know that each element is has its own symbol chemique, like chemical symbol. And these symbols are things which you already did at secondary school. An element and this symbol, for example, I can give you azure. Azure, that's a name for silver in English. Yeah, azure is symbol, chemical symbol is Ag, is Ag. Then arsenic is chemical symbol is As. Yeah, so that's all that. Then definition of an atom. What is an atom? Un atome est une quantité de matière infiniment petite. This is atom is the quantity of matter which is infinitely small, like which is very small. I can say very small. You remember in your secondary, if my mind can serve me right, we used to say an atom, this is the smallest unit particle which takes part in a chemical reactions. If my mind serves me right, that's an atom. It is just the same thing. So an atom is a quantity of matter which is very small. So it's l'ordre de grandeur, the mass is, so the magnitude of its mass, the mass of this atom is 10 to the power negative 26 kg. That's the mass, which is, this mass, if you imagine 10 negative 26 kg is very small, like something which is really, really small. And such dimensions, the kk Armstrong, which kk Armstrong, this is a unit which is a very small unit which is used to measure length of something, like something which is very small. So we know that, you should know that, you should put in mind that the length of this atom is kk Armstrong, meaning it's very small, and you should put in mind that one Armstrong is equal to 10 negative 10 meters. That's what you should put in mind. And yeah, and an atom, l'atome n'est pas insécable, meaning an atom is not unbreakable, which means an atom can be breakable. You can break an atom, but when you break it, sa rupture conduit à des particules identiques par toutes les matières. We see that if we break it, this breaking will give us particles which are identical in all their matter. Yeah. So I don't know if there is any question on the first part. If there's a question, you can ask me. If it's clear, you can go on. If there's a question, you can ask.
May you kindly repeat on the Armstrong part?
Also, for Armstrong, I was saying that the atom also times is its length is the length of an atom is very small that you can't even measure it. That's why they just say third dimension A, the kk Armstrong, meaning it's just the length is very small. It's just Armstrong, basically Armstrong, this is the unit which is used to measure things which are very small, like you can say meter, meter, centimeter, then you go to millimeter, then Armstrong is just below that. Yeah, that's a smallest unit. I don't know if you have understood though.
Yes, thank you very much.
So yeah, so when you go further, there will be some questions which will be demanding you to change from meter to Armstrong. So this one Armstrong is equal to 10 negative 10 meter. Should do. Keep it by heart. You should know this one. It's very important. So we'll continue. So after that, we have looked at what an atom is. Now we'll look at what a molecule is. So les atomes associés pour donner des molécules. So we see that atoms, they associate each other. They bond each other to give a molecule. So a molecule basically is the coming together of atoms. That's what forms a molecule by definition. Une molecule est par conséquent une union d'atomes. La molecule comprend un. When I say un, I mean it is made of same element. Like for example, here on our example, I've got oxygen. Oxygen is made of one element, which is I can say O here, which is O. So when you combine these atoms of an element, we say a molecule. It can also be the element, the atoms. Here we have got hydrogen and oxygen. Hydrogen and oxygen, it contains two atoms, which is hydrogen and oxygen. Then plusium atoms, I can give an example of sulfuric acid, which contains hydrogen, sulfur, and oxygen. Like there are a lot of those things make up an atom. So, elle est selon les cases di or polyatomic. So you can say monatomic, diatomic, or polyatomic. Yeah. So here, I don't know if there's any question under molecules. Yeah, if there's no any question, I know this is a straightforward thing. Yeah. But actually, I was expecting a question here, like for molecules, what's the difference between a molecule and a compound? You have to know the difference between a molecule and a compound, because we can say, there are ionic compound, covalent compound, and all sorts of compounds, and there are also molecules. What really is the difference? That's the question I was supposed to get, because most of us, we think that a molecule only contains negative ions. For example, hydrogen, and no, for example, nitrogen and nitrogen. But here I've got sodium chloride. Sodium chloride contains a positive and a negative ion. So what's the difference between a compound and a molecule? We see that molecules contains, like molecules, basically molecules contains atoms as we defined it, which are joined together. And these atoms can be atoms of the same element. When I mean the same element, like oxygen is of the same element. But for a compound contains atoms or elements which are joined together, which must start on two elements, meaning one element is different and the other element is like they are different, two different elements. So in conclusion, we can say all compounds are molecules, but not all molecules are compounds. That's what you should put in mind. All compounds are molecules, but not all molecules are compounds. That's what you should put in mind. Yeah. So we'll move to our next page. Yeah, we're going to talk about mole and mass molaire. These are things which you also learned at secondary school. Yeah, and things which I can say things which are very simple. So we see that one mole, the atom equals to n atoms, avec n est le nombre d'Avogadro. So by definition, un mole du atom, by definition, here's the definition. Un mole du atom, c'est a quantité contient n atoms. One mole of an atom, it is a quantity which contains n atoms. Or we can say more basically, more on itself, we say more is the unit SI de mesurer de quantité de matière équivalente à celle d'un système contenant autant d'entités élémentaires qu'il y a d'atomes than 12 grams de carbon 12. So a mole, it is the SI unit used to measure the quantity of matter, yeah, which is equivalent to the system which contains as many entities elementary as those ones of atoms of carbon 12. Yeah, as many entity elementary of atoms than in 12 grams of carbon 12. So what do I basically mean? So I mean, one mole the atoms contains n atoms, and n atoms, n it represents Avogadro. Then Avogadro, the formula for Avogadro is this one. This is a constant for Avogadro, which is 6.023 times 10 to the power 23. This one you should know it by heart. Okay, you should know this one by heart. And if you say un mole, I want you to get me clear here. When I say un mole de atoms equals to n atoms, and I defined un mole de atom as in the quantity contain n atoms. So this is a quantity which contains n atoms. And by definition, we defined an atom as a quantity of matter. And all of you know the definition of mass. Mass, this is what? This is the quantity of matter which is contained in a substance. And and when you say un mole de atom, this is a quantity which contains in n atoms, the quantity which contains in an atom. For example, if I give you carbon, which has the mass of 12 grams, its quantity will be 12 grams definitely, because we said mass, this is the quantity. This is the quantity of matter which is contained in a substance, and here our substance is an atom. So we can say, if I give you carbon, you say 12 grams of carbon is equal to n atoms. What of one atom is equal to x grams of carbon. So that's how we, like when we go down, that's how we'll be calculating if they want you to find, the what? If they want you to find the mass of an atom, or the mass of one atom, yeah, if they want you to find the mass of one atom, that's how we'll be going about. And the other question must be, why, when, like here, the other definition, why did they use carbon when defining? Why did they use carbon when defining a mole, like a mole basically? Why did they use carbon? They used carbon simply because you know that when you write the chemical formula of carbon, it has 6 proton number, which is 6 atomic number, and the mass number, its mass number is 12, which means that for carbon, basically, carbon, it has the same number of protons and the same number of neutrons. That's why most of the times they use carbon, even if you see that, if you go down, in calculating unit mass atomic, we will look at that. Don't worry, look at that mass unit atomic. If they define in mass unit atomic, they use carbon-12 because carbon-12 naturally is 99% in its natural form. And like at first they wanted to use hydrogen, but when they wanted to use hydrogen, they discovered that the isotopes of hydrogen, they are abundant on Earth. And when they discovered that, it was difficult for them to get a good average of sinker. So they left hydrogen. After they left hydrogen, they tried using oxygen in terms of definitions. Oxygen, they found out that oxygen can react with a lot of metals. And they said, no, this is not the good way of defining it using oxygen. That's when they went to carbon. Carbon-12 actually is itself, which is very abundant on Earth, rather than carbon. Carbon-14, we have got, there are isotopes of carbon. There's carbon-14. Carbon-14 is not really abundant on Earth. It's only found on fossils. Like if you want carbon dating, if you want to do carbon dating, those things. Yeah. So basically, a mole of an atom is the quantity which contains n atoms, and n atoms is equal to Avogadro, and Avogadro is equal to 6.023 times 10 to the power 3. Yeah, that's the definition of a mole. Then after that, we define what is masse molaire. Masse molaire. Masse molaire est la masse d'une mole. This is a mass of a mole. Some value, this is like basically this is a mass of, I can say 1 mole of an atom, or yeah, it's a mass of 1 mole of an atom when we get this element. For example, carbon, its mass, that's mass molaire. Carbon has a mass of 12 grams, so its mass is what? 12 grams. That's the definition of mass molaire. Ça value lié au choix des éléments. So its value is linked to the choice of the element which you choose. If you choose carbon, you have to know the mass of carbon. If you choose oxygen, you have to know oxygen is 16, which is 16 grams. You have to know its mass. And the mass atomic, the set element in the base. So its mass atomic, it basically means its mass, basically. Yeah, it means the mass. So mass molaire is something which you already know, which we did in Zambia. C'est-à-dire à la masse value de la masse de n atomes de l'élément de base. La mole représente l'ensemble de n particules élémentaires. So a mole, it represents a set of n particle elemental. I said elemental, these are just protons, neutrons, electrons. So in a simple terms, you can say the mole represents the mole represent an atom. We can say an atom because particular elemental is just the set of neutrons, protons, and electrons combined together to form an atom. Yeah. So example, I've got moles of atoms, the fer, which is ion, moles, the molecules, H2O. Yeah. That's basically mole and mass molaire. I don't know if you are clear or you want me to explain something here. Is to tell me if you're not clear on something. Yeah. But these are things which we already know. And so basically you have seen chemists like from where I am now is like the things which we already did in Zambia. So we'll continue. The constituent de l'atome. What does an atom constitute? Or like what does an atom contain? So we see an atome est constitué d'un noyau central chargé positivement et retour duquel gravitent des charges négatifs élémentaires or electrons. So we see that an atom it contains a nucleus. Noyau is nucleus, which is on the center and which is charged positive. And around this nucleus, we see that there are electrons which are charged what? Negative. So the charge of electrons, you have to know this by heart also. You have to know that the charge of electrons is negative 1.602 times 10 negative 19 coulombs. That's the charge. And the mass of electrons is 9 point. So in French, point is mostly written using a comma. Yeah, you should change how you write, like in Zambian what you used to write a point with the a dot, but in French, if you write a point with a dot, it means multiplication. So the mass of electron is 9.1091 times 10 negative 31 kg, which is equal to 0.00055 unit mass atomic. This you will learn about this. This is the mass actually which they usually use when measuring what? When you are measuring an atom, they use this mass, unit mass atomic. And here I wrote something which is noté, c'est la même avec 9.10091.10 negative 31. So you have to note that if you if you see this point, it means it is multiplication. So that's what I'm saying. When you are writing, you have to be careful. Know it when it's, for example, you write this point, you put it in between of 9, like the point with like a dot, you put it in between 9.1011091. That would be a mistake. The prof, like here, the professors here, they'll think like you are multiplying 9 times 1091. So you should be avoiding that mistake, which is like, that's what usually kills people. Like you can know everything, but those silly mistakes, those are the mistakes which most of the people, they fail because of those mistakes. So, le noyau est formé de deux particules élémentaires. So the nucleus is formed by 2 particles élémentaires. This is the proton and the neutrons. You know this already. Qui sont des noyaux de hydrogène portés chaque une charge positive égale et opposée à celle des electrons. So the protons which are so the protons, you know that the protons are the ones which makes up a what? A nucleus, one of the particular elementa which makes up a nucleus, which is positive charge, and its charge is opposite. It is opposite, I can say it is opposite at those one of electrons. So each charge, the charge is the charge is positive 1.602 times 10 negative 9 coulombs. So for a proton is positive, and if you look for electron, the only difference is just the negative. Electrons is negative 1.602 times 10 negative 19 coulombs. But for a proton, if you look down here, the one on top is a mass, the one down here is that's a charge which is positive 1.602 times 10 negative 19 coulombs. Then its mass, the mass of protons is 1.675 times 10 negative 27 kg, which is equal to 1.0073 unit mass atomic. So these you have to know them by heart. Starting from with the electrons, with the mass of the protons, the charges, you have to know them by heart. Because, yeah, quite all right, when you go to universities, they'll be giving you, like, most of the time they put down that the mass of a proton is this, the unit mass atomic is this, they put down. That's the good part. That's why, yeah, but for yourself, you have to know it. You just have to master it. Then the nucleus is also made of the neutrons. So neutrons, these are particular neutres, or the masses voisins de celles de proton. So we see that these are particular, you can say, neutral, I can say neutral particles. These are neutral particles, and their masses are voisins. It has enabling mass of those ones of a proton. Like the masses doesn't really vary that much with protons. So as you see here, for protons 1.675 times 10 negative 27 kg, but and for neutrons you see 1.675 times 10 negative 27 kg. So there are sometimes you would find for protons you would find 1.673 times 10 negative 27, but the masses will always be voisins, like they'll always be neighboring masses. They won't vary that much, the masses. Then its unit mass atomic is 1.0087, yeah, unit mass atomic. Then the charge of the charge of a neutron, since we've said the neutron is neutral, yeah, a neutron is neutral, its charge is 0 coulomb. So it doesn't have any charge. Yeah. So we've seen, basically we've seen what an atom really constitutes, like what an atom contains. So right now we're going to see the characteristics of an atom. What are some of the characteristics of an atom? So we know that the noyon of an atom contains the protons and the neutrons. So we know that the noyon contains protons and the neutrons. Protons and neutrons, so the nucleus. So these protons and neutrons collectivement s'appelle nucleons. So we see that the protons and neutrons in a collective part, or in a I can say when you bring them together, they are called nucleons. Like if you get protons and neutrons together, they are called nucleons. Le nombre de protons fixe le charge du noyon. Pourquoi il fixe the charge du noyon? So we see that the nombre de protons is the one which fixes the charge there, or is the one which fixes the charge of a nucleus. Why does it fix the charge of the nucleus? It's because we see that the proton here, according when we are looking at the constituent of a proton, we see that the proton is positive charge, and a neutron, which both of them makes up a nucleus, is neutral. It doesn't have any charge, which implies or which entails that a noyon will take a positive charge. The nombre de nucléon fixe la masse du noyon. We see also that if you see the mass of what? Of an electron. The mass of an electron is très petit. It's very, very, yeah. Don't know. Yeah, you can see the mass of an electron, which is 10 to the power negative 31 kg, which is, imagine, 9.1019 times 10 power negative 31. Like, if you write something which is 10 power negative 31, it's something which is like 0.000, which is something which is very small. So we consider the mass of an electron to be negligible. Donc, on va voir que we are going to take the mass, we are going to see that this one goes for the atom in general. We're going to see the atom in general having the mass of atom being determined by the nucleus, the protons and the neutrons. Yeah. So we see that the mass of a noyon is determined by protons and neutrons, and also see that the mass of an atom is determined by protons and neutrons also. Yeah. Then we're going to look at what is numero atomic, what is numero atomic, and what is nombre de masse. So numero atomic is something which you did in Zambia. It's the atomic number. Yeah, it just means atomic number. Atomic number is the nombre de protons, like it is the number of protons. Atomic number is the number of protons, and Z désigné également, we see that Z désigné également nombre de les electrons qui tuerait les noyaux puisque l'atome est électriquement neutre. So we see that Z also design, or Z, you can the atomic number, Z represents atomic number. We see that the atomic number also, you can also use the atomic number to define the number of electrons. So we see that if we've got 6, for example, if I've got 6 protons, meaning I've got 6 electrons. So the atomic number is always equal to the proton, the proton number is always equal to the electron number. And if both of them, they designate the atomic number, yeah. And since the electron number is equal to the proton number, if I've got 6 protons, it means I've got 6 electrons. So if protons of said is positive and electrons of said is negative, and if we add the positive and the negative of the same number, we get a what? A 0. This is which makes an atom, generally an atom, the whole atom to be neutral. Yeah, that's all of it. So like if they ask you what is number atomic or number atomic, you can say number atomic is le nombre de protons, Safi. Yeah, the nombre de mass. Nombre de mass is something which you already know also, the mass number, which is denoted by A. Et le nombre de nucléons, soit les somme du nombre de protons et du nombre de neutrons. So we see the number, the mass, it is the number of nucleons. Nucleons, we will say these protons and neutrons, yeah. So you can say it is the number of the nucleons, you finish from there. Or you can say this is the sum of the number of protons and the number of neutrons, just as one and the same thing. So the number R is Z, so the number entier. So we see that the mass number and the atomic number, they are integer numbers, like they're integers numbers, and it characterizes atom ou son noyau. So it characterizes an atom, or is nucleus. Yeah. So this number, basically it characterizes an atom or is nucleus. So une espèce donnée de noyau s'appelle un nucléate. I think you remember in secondary you did something like nucleate notation, like how to present something in nucleate notation, those things. So these are things which I'm basically talking about here. Yes, how you can present an atom according to a nucleate notation. So un nucléate est donc un noyau avec une masse et une charge déterminée. So we see that a nucleate is a noyau with a mass, it's a nucleus with a mass and a charge déterminée. And we have said that a mass, when you say a mass, they just mean the mass number. And when they say the charge déterminée, we know that the atomic number is the one which determines the charge. They are just talking about the atomic number. On dit qu'il est présenté par la notation. So this one is represented by the notation. This is the notation which you present. X represents an element, Z represents an atomic number, human atomic, the number of protons, then R represents the mass number. Yeah, so like for example here on top is atomic number, down here is the mass number, atomic number, the mass number. Like for like I started with helium. I've got the atomic number of 2 and the mass number of 4. chlorine in French, has the mass number of, there's the atomic number of 17, the mass number of 35, you continue like that, and yeah, and I want you also to note that there's no problem, ce n'est pas le peine pour exchanger les notations. Par exemple, vous mettre un à la route et les Z à la base. So it's not a problem if you exchange, like you put, like you have seen your X, this is your element, your atom, then you exchange, you put your Z down and your R, your mass number on top. There's no problem, and actually that's what we usually use in Zambia, like the mass number is on top and the atomic number is down, if you can remember correct. Yeah, that's what which I would also prefer you to use. Like you, when I was making these notes, I didn't find a proper photo to place for this. I wanted A to be on top and Z to be down. Yeah, but either way, there's no problem. Yeah, either way, there's no problem. But I would advise, like the ones which, basically at my school, the ones which we usually use, we have mass number on top and the atomic number down. Yeah, that's all about the characteristics of an atom. Now we're going to go, I don't know if there's any question up to there. If there's any question, you can kindly ask.
I think there are some questions in the chat section.
There are some questions?
Yeah, in the chat section.
Okay, let me check. I wasn't checking the chat. Okay, ah bon? Okay, Nathan Mapalo. He asked a question. What of an atomic fission? Doesn't it split atoms? Yeah, I know where this question is coming from. When you talk about atomic fission, you talk about an atom like rubidium. Rubidium, I can say it is highly radioactive. It is highly radioactive in such a way that it breaks. When it breaks, it splits and it forms new atoms. That's where I think where you are going to. So that I can say an atom, generally an atom, when you break an atom, you form, when you break an atom, I'm not saying about radiation here, like for fission, this is a spontaneous, your physics, you used to say your physics, if I remember correctly, is a spontaneous breaking of an atom, yeah, which releases radiation, and that that atom which is broken is highly radioactive. So a general atom, like for example, if I break I can get carbon. Carbon is not radioactive. Carbon 12. I'm not saying carbon 14 actually is radioactive, but carbon 12, or I can say, let me just say sodium. If I break a sodium, the atom which I'll make is an atom which is identical to the sodium. But the one which you are talking about, fission, this is an exception case. This is for atoms which are highly radioactive. Those are the atoms which split. I don't know if I've answered your question for that one.
Yeah, clear. Thank you.
Mm-hmm. So can you please repeat on the calculations? Alex, the calculations, which calculations? You can help me, Alex?
Yes, on calculations on constituent de l'atome.
Oh, okay. You mean under more or beyond? You mean the one they charge for electrons or what, Alex?
Not that one. The calculations below.
Below.
The same constituent de l'atome.
This one for the point, the shiny. Huh? This one for
No,
the
so
one which,
not those. The ones below.
below. Where
Yes.
exactly? This one.
Yes. Yeah.
How you get the charge of a proton or what?
Yes, exactly.
Oh. So for the charge of a proton, like as I said earlier, these are things which are like the charge of a proton, the charge of electron, the charge of neutrons, yeah, all those things, they are fixed what? Fixed, like they are fixed. You just have to know them by heart. So the mass of a proton, which is 1.675 times 10 negative 27 kg. Yeah, this is the mass, which is the mass the mass fundamental of a proton, which you're supposed to know and which you're supposed to have it by heart, and which is equal to 1.0073 unit mass atomic, which is also, you have to also know it by heart. This is the unit mass atomic. We're going to learn about it. As I told you, it's a mass which is used to measure an atom. Then, yeah, even the charge also is a constant. Like you just have to know them by heart. They are constant things which you have to know by heart. And I said that the mass of a proton and the mass of a neutron, they are masses which are voisin, which means they are neighboring masses. Yeah, so here, like, that's what I've seen, the mass of a proton. If you see, the mass of a proton is 1.675 times 10 negative 27, and the mass of a neutron is 1.675 times 10 negative 27 kg, which is similar. So I told you that there are some times you would find that, for example, I said the mass, they give you the mass of a neutron is 1.67, maybe 3 times 10 negative 27. Like it will be varying a bit, but not that much. It can vary a bit, or it can be same, completely same, or vary a bit. That's what I explained. I don't know if it's clear, Alex.
Yes, it's clear now. Thank you.
Okay. Then Lawrence Cham was asking if you can do some questions, but actually, like, I've prepared some questions for you, so don't worry about that. I'll send some questions in the group. You try them, and after trying them, you send me the answers. You see the question which which is basically on these things. You try them, and when you try them, you send into the group, or you send it to me personally, the answers which you have found. Then yeah, then we'll see the way forward. If I see there's a need of explaining, I'll come and explain. Like I planned maybe 30 minutes before the lesson ends, I'll be explaining the questions. So I will give you some simple exercises. Then Ruben asked a question, when doing the calculations in faculties, what do you, so when doing calculations, most of the times we find the answer first in unit mass atomic. Then after that, you can leave it in unit mass atomic. It depends. Like it depends. You can find your answer in unit mass atomic and leave it there. Or if you want, you can change it in kg. Doesn't matter which one. Yeah, if you just know how to change it in kg, if you just know how to change it in unit mass atomic, which you are going to learn when you go down, when you go, yeah. I hope it's clear.
Yes, it's clear.
Mm-hmm. Yeah, that one, I think I explained it. The one where the order of the atomic number and the mass are swapped. I think I explained it like here in French, like they can swap it, but most of the times, like I would prefer you to use the one like where there's, I think you can see here, someone asked a question, why is he observed, yeah, that's really good actually. He observed that the atomic numbers on top, the mass numbers down, but in Zambia, the mass numbers on top and the atomic numbers down. So you can use whatever you are comfortable with. Yeah, but yeah, the one just use the one which your schools teach you. When you go to different schools, they will teach you. Just stick with the one which your school will teach you. I hope it's clear. I don't know where I oppose. I don't know, someone asked a question about on or the one for like you wanted to know in terms of the charges, where here I say that for the protons, where it is saying someone asked a question where I should explain what oppose, like what I was meaning by saying oppose. I say the electrons, like opposing are those of the electrons. I am simply saying the opposite. You have seen the opposite. If you have seen the charge of a proton, the charge of a proton is similar to the charge of an electron, but for a proton is what? It's positive, and if you see for electron, you see its charge is negative, meaning it's opposing each other. It's equal, but opposing each other in terms of charges. That's what I meant. Yeah, I think all that is clear. So I think I've answered your questions. So I've looked at what an atom is, what constitutes an atom, what a more is, characteristics of an atom. So we'll continue now with an isotope. We really don't have enough time. Yeah, I'll continue with an isotope. So before I continue, is it clear? Is it clear everything which I've taught?
Yes.
It's clear? Okay, thank you very much. So we're going to continue with an isotope now. So isotope is something which we learned already in secondary. So un isotope des atomes peuvent avoir un même numéro atomique Z et des nombres de masse A différents. So basically, these are atoms which can have the same atomic number, but different mass numbers. So what is an isotope? Isotope, these are atoms which have the same atomic number, but different mass numbers. On dit qu'ils sont des isotopes du même élément. We say that there are isotopes of the same element. So what I mean is you can have helium 1, helium 2, helium 3, you know those, like they are same element, but they've got different mass numbers. Yeah, same number atomic, but different mass numbers. These are things which we already learned. Ils ont toujours des propriétés chimiques très voisines, mais ils diffèrent par le massif de leur noyau. So they always have chemical properties which are what? Very close. Like if you remember your chemistry very well, a chemical reaction is determined by the electrons, like the reactions of electrons, losing electrons, gaining electrons. Those, like, that's how a chemical reaction usually happens. Like chemical reactions depends on what? Electrons. And if chemical reactions depend on electrons, we see that the number atomic of an isotope doesn't change. If the number atomic of an isotope doesn't change, it means the electrons itself doesn't change. If the electrons doesn't change, it means all these hydrogen 1, hydrogen 2, hydrogen 3, for example, they all have the chemical reactions which are très voisins, which are very close, but mais ils diffèrent par leur masse de leur noyau. But it is different by the mass of their nucleus. Mass number. Mass number is determined, you know that mass number is determined by protons and neutrons. And we say that the protons are always the same. If protons are always the same, it gives us an implication, or we'll think directly that the neutrons are the ones which are changing. If the neutrons are the ones which are changing, which will give us that the mass of each will be what? Will be always different. The mass will be changing. So its physical properties will be different, but its chemical properties will be always voisin or close, the same. Yeah, that's all about it. And en grand nombre, the éléments existent à la tête neutre sous forme du mélange des isotopes. So a large number of atoms or elements on periodic table, when you see those elements on periodic table, most of them, they are a combination, or they are a combination of what? Of different isotopes which are combined together to form an electron. Yeah. So that's all about an isotope. Then I've got some examples of an isotope. There's there's an element here. There's lithium. Lithium has we see has a proton number of 3. Then the mass number is always what? You can be, there's lithium with a mass number of 6 and lithium of the mass number of 7. Then its abundance, when I say abundance relative, is what percentage is found on Earth, like what percentage is found here on Earth or in, yeah. So the abundance of lithium with the mass number of 6 is 7.52%, and the abundance of lithium with mass number or number de mass 7 is 92.48%. Then oxygen has 3 isotopes. We have got 16, 17, and 18. and the what? For the mass number of 16, its abundance is 99.75%. So the mass number of 16 is the one which has high abundance. Then the mass number of 17, its abundance is 0.037. And lastly, the mass number of 18, its abundance is 0.204. So when you add all these abundances, they must be giving you 100%. So the first one, when you add them, they must give you 100% or 99.9999. If you add this one, it must give you 100% also. Donc, si un élément présenté plusieurs isotopes, sa masse expérimentale est en moyenne pondérale de la masse atomique des different isotopes. So they are saying if an element has different isotopes, yeah, assume an element with a lot of different isotopes. For example, I can give hydrogen has got isotopes. Its mass experimental, the mass experimental is its mass is the moyenne, or is the average of all those isotopes added together, and and divided by what? By 100. This is the formula which we have here. This is the mass for us to find the mass average of the isotopes. We use this formula where M is equal to summation I. Summation means the sum of AI, MI over 100. So MI is the mass atomic. The mass atomic most of the times is in UMA, unit mass atomic. Yeah, that's the mass atomic. They usually give you, don't worry about that one. If they give you a question, they usually give you the mass atomic. And AI is what? AI is the abundance of how the percentage which you can find in the environment or in air. That's AI. So they'll also give you the abundance. So they can give you the abundance, the mass atomic, and they tell you to find the mass, the average mass. Or they can give you the average mass, the average mass and some mass atomic, and they tell you to find maybe one of the abundances. So that's how it usually that's how it usually goes. I don't know if let me check if I've got an example. Just wait a bit. I don't know, can you see? Can you see my screen?
Yes, we can.
Okay. So I've got an example on isotopes here. Yeah, here's my example. So example, I think, can all of you see the example?
Yeah.
Yeah, the chlorine, which is chlorine in French, naturally possède des isotopes. This is the isotope. Chlorine 17, what I was talking about, atomic number 1735, with its abundance 75%, its abundance, and the other isotope of chlorine 17 proton number and this mass number 37, and its abundance 24.6%. So avec the mass atomic, this is the mass atomic which I'm talking about. So when you're calculating the mass average, don't get the mass which is here on chlorine like 1735 and the 1737. No, they usually give you the mass atomic. So the mass atomic is 34.97 and the unit mass atomic, and the 36.97 unit mass atomic. So so M1 is for chlorine 35, which is the first isotope. Then M2 is for chlorine 37, which is the second isotope. So how should I calculate my average mass? So my average mass, I'll say, I'll get the mass atomic, which is 34.97 times 75.4 divided by 100, which is the total, the abundance is 100%. As I told you, like when you add the abundance together, they must give you 100%, plus 36, which is the atomic number, 0.97 times the abundance 24.6 divided by 100, which will give you 35.46 unit mass atomic. This is the unit which you use. Then the mass atomic, the atom, the chlorine, 35.46 unit mass atomic. Then the mass molar, the chlorine, you just write the same one. You just add the gram. That's all. That's the mass molar. So that's how basically that's how you calculate for the average mass. So we can go back to yeah, we can go back. I don't know, was that clear?
Yes,
Yeah.
it was.
Yeah, okay. That's nice
Yes,
if
yes.
you're understanding. The most important part is you are getting the base. If you know where to start from, you won't have any troubles when you go to school. Since if you know these already, I know even though if I don't finish, the things which I've taught, if you know them, you read them fastly and you go to other things which you don't know, and it will save you time. So we'll continue. So we have talked about an isotope and how to calculate the average of these isotopes. Now we're going to talk about default the mass and the energy de liaison du noyon. So basically, what usually happens when you're forming an atom, when you want to form an atom, when you want to form a noyon, what usually happens is there will be protons and neutrons which are separated, and if they want to form a noyon, these protons and neutrons, they have to combine together, like they have to come together to form a what? A nucleus. Noyon is nucleus. So what usually happens, so here we're going to look into what usually happens when you're forming a nucleus. When you're forming a nucleus, when a proton and a neutron join together to form a nucleus, what usually happens? That's what we're going to look at here. That's default the mass and the energy. Under default the mass and energy, liaison du noyon. So what happens? Let's considerons la formation du noyon de helium à partir de ces nucléons. So we've got helium here. So how is helium formed? So helium, the noyon of helium is formed by, here just, don't get confused here. Here is just an illustration. So we have got 2 protons and 2 neutrons. So when these 2 protons and 2 neutrons, they will add together to form like 2 protons and 2 neutrons. So this is what is formed after adding together. So yeah, when you go down, these 2 protons and 2 neutrons will add together finally to form a helium atom. So I want you to listen to me attentively on this one. So what usually happens is, each time a noyon or a nucleus is formed, there's some radiation which takes place. Some radiation is lost. When you are forming, when the nucleons and the protons come together, there is a radiation which is formed. And when this radiation, when the radiation is released, is rebalated, we see that the final, the noyon which is formed, the mass of the noyon which is formed, the mass of the nucleus which is formed, will be always lesser than the protons and the neutrons when they are separated. So when they combine, there's some radiation which is released. When this radiation released, this radiation, when it released, there's a loss of energy also, and there's also a loss of mass. So yeah, so there's also a loss of mass, and as a result, the noyon which is formed, its mass is always lesser than the mass of the protons and the neutrons when they are separate. So, so this brings us to our definition of default de mass. So default de mass, per definition, I can say default de mass per definition is the difference between the total mass of the nucleons, that's the protons and the neutrons on rest, with this is the difference between the total number of what of neutrons, this is protons and neutrons, and the mass of the noyon which is formed, which brings us to, so most of the times what usually happens is they'll give you the mass real. I think you can see the mass real of a noyon. The mass real of a noyon here they have given us is 4.0001503. If it was supposed to be unit mass atomic, yeah, suppose the unit is unit mass atomic. So they always give you the mass real of a noyon, the mass real after it was formed. Then for you, your job will be to calculate the mass theoretic, the mass of calculation, the mass theoretic when you're calculating, meaning you won't consider any loss of mass, any loss of radiation. So the one for calculating, you get the actual mass which the noyon was supposed to have. That's the mass theoretic. Then the mass real is the mass which the noyon has after the radiation. After, if you like, the mass real is always called the mass experimental. After you do an experiment of joining the neutrons and the protons together, the mass which you obtain, that's the mass real, which is always lesser. But the mass which you calculate is the mass theoretic, which is you assume that there was no that of loss of mass, there was no that of there was no default mass. Yeah, so you do your calculations, and if you have observed how you do your calculations, yeah, here you should also listen to me here. How you do your calculations. You have seen helium. If you see helium has a proton number of 2 and a mass number of 4, meaning helium has 2 protons. If the mass number is 4, has 2 protons and 2 neutrons. So what you do is, for you to find the mass theoretic, you get the first one is for proton, 2 proton, which 2 proton times the unit mass atomic, the one which we learned. I don't know if you still remember it. This one. We are on proton. So when you're calculating, that's what I'm saying, you have to have it by heart. We usually use this one, the unit atomic mass. I think you can see it, this one. For a proton, and for neutron, we use this one. I think you can see it. So yeah, we use this one. So that's how when you're calculating the default mass. So there is 2 times the mass which I've told you, the unit mass atomic 1.00727 plus 2 times 1.008885. This is for this is the number of neutron, which is 2 times the unit mass atomic, which will find your answer in unit mass atomic definitely. Then after that, for you to find your default mass, the mass which is your default mass is the mass, like I said in simpler terms, the mass which was lost. That's the default mass. So for you to find the default mass, you usually do the mass theoretic, which is the mass which you have calculated, minus the mass real, which is the mass which they will give you. They will do an experiment for you. They do an experiment for you, then they will just give you an exam. They just give you the mass real. So the mass theoretic, after you find it, you just subtract it with the mass real. So when you do your subtractions, you'll find that your answer will be 0.03176 unit mass atomic. So this is the mass which was lost, default mass. So yeah, that's all about default mass. So la réaction nucléaire s'accompagne d'une perte de la masse. Oui, c'est accompagné d'une perte de la masse, encore appelé default de masse de 0.03176 unit mass atomique, qui est la différence entre la somme des masses des protons and the neutrons and la masse du noyau de helium. So here basically you tell us that the reaction, the nuclear reaction is accompanied by the loss of mass, which is called default of mass of 0. This default of mass, after I've calculated, is like it's always different. It cannot be the same according to, it depends with the element. So according to our calculation is 0.03176 unit mass atomic, qui est la difference, which is the difference between the sum of the masses of protons and neutrons and the mass of the noyau helium, which is what formed, the mass of the nucleus, which is what formed. So, cette perte de masse se trouvait sous forme d'énergie, qui sont des grandes équivalentes. So here saying, this mass, this default, the mass, is found in form of energy, which has two magnitude equivalent, or which has two magnitude equivalent. Here we bring in, like, we said that when a proton and a neutron is combining, it loses radiation. That radiation is in form of energy, and that energy is like, when it loses, each time it loses energy, the mass also reduces. Each time it loses that radiation, which is in form of energy, the mass reduces. That's why they're saying the mass, the default mass which you have found, is connected to energy. It's always connected to energy because this mass is connected to the radiation when you combine the neutrons and the protons together. So the formula we use, and the most famous formula of Einstein, which is energy is equal to mass times times what? Times speed of light. Yeah, mass times speed of light squared. So mass must always, you should get this, must always be in kg. Then speed of light must always be in meter per second. You should get this. So yeah, so for you to calculate the energy, what usually happens, for you to calculate the energy of default the mass, or for you to calculate the energy of the energy which was lost, the first step is you have to find, we'll do that in exercise. I've got simple exercises which I'll give you and you'll try, and yeah. So always the first thing is you have to find default the mass. If you find the default the mass which was lost, then you have to turn that mass into kg, because energy is calculated in kg. So don't worry about turning into kg. We'll learn, like when we go down, we'll learn how to turn unit mass atomic into kg. So if you turn it into kg, then now you know the speed of light. The speed of light is 3 times 10 to the power 8 meter per second. Yeah. So for that, I was supposed to put it the speed of light here, but I think when I was writing, I forgot something. So I'll indicate and I'll send it in the group, the speed of light, but it's something which you already know. The speed of light is always 3 times 10 to the power 8 meter per second. Yeah, so the speed of light is constant. So the only thing which is challenging when you're calculating the energy, or the energy which was lost, is the mass. So the mass, you have to know how to calculate default the mass, and we have learned how to calculate default the mass. And after you have calculated the mass which was lost, you can turn it into kg, and after you have turned it into kg, you just multiply it, m times c2, then you find the energy. The energy will be found, the energy, if it is kg times, the energy will be always found in what? In joules. The energy will be always in joules. Yeah. So there are some things like the things which I've talked about, like the things which I'm from talking about. There are some definitions here which I feel that you have to know. What is energy de liaison and energy de cohésion? So energy de liaison, elle définit l'énergie libérée lors de la formation du noyau à partir des particules élémentaires. So energy of la liaison. So liaison to I can say liaison is something like to come together. So the energy of liaison is the energy which is lost, libéré, during lors de la formation, during the formation of a noyau from the particular elementa, which is protons and neutrons. And its value always is negative. If like in chemistry or in physics, if it involves losing of energy, the value is always negative. Like, yeah, it's always negative. Then the energy de cohésion. Energy de cohésion est l'énergie qu'il faudrait apporter au noyau pour les dissocier en ces nucléons. So the energy of cohesion, this is the energy which must be carried by, or which must be absorbed by a nucleus for it to dissociate, for it to separate into different nucleons. So it's possible for you, after you form your atom, then you desire, like, you want let me just separate this atom. You can apply heat to it, or you can apply energy to it, and if you apply energy to it, it will separate differently. That's the energy de cohésion. So c'est une énergie positive. So energy de cohésion is denoted as ECH equal, yeah, ECH, that's the energy de cohésion. Then E, just E, that's the energy of liaison. So energy de cohésion is always equal to energy de what? Liaison. So when you find the energy de cohésion, there's no need of you finding the energy of liaison, because it's always equal. The only thing which you have to do is just to include the negative. Yeah, if they say give us the energy of liaison, the energy used to the liberation, you have to just put a negative. That's all. Then there are some things which you are supposed to note. This one usually they sometimes ask you to, like, electron volt. This is also a unit of energy, electron volt. Yeah, there's something which you have to note. So electron volt is a unit of energy which is lesser than joules. Then there's a mega electron volt. So it is joules, a mega electron volt. Then electron volt is the smallest. So mega electron volt, if you want to change to unit mass atomic to mega electron volt, this is the formula which you have to note. This is like you have to know it by heart. So 1 unit mass atomic is equal to 931.5 mega electron volt. For example, we have found our unit mass atomic, the default mass atomic, we have found 0.03176 unit mass atomic. So for us to find in electron volt, we'll say 1 unit mass atomic is equal to 931.5 mega electron volt. Then what of 0.03176 unit mass atomic is equal to X. Then you do your cross multiplication, and you definitely find your answer in mega electron volts. Yeah. Is it clear? I don't know if you have understood all that.
Yeah.
Yeah, if you have understood, yeah, that's nice. So there are some remarks which I want you to note. So il est commode d'utiliser une unité plus petite que les joules. C'est les electron volt, which I was talking about. So it is common to use a unit which is very small, than joules, which is what an electron volt. So sometimes you can find your answer, like for example, the one for energy is equal to MC2. You'll find your answer in joules, but they will tell you we want the answer to be electron volt. You have to change it in what? Electron volt. So by definition, electron volt est l'énergie d'un électron soumis à une différence de potentiel de 1 volt. This is the energy of an electron which is underput at a potential difference of 1 volt. So basically, like for under electron volt, what you should know that what you should, they don't usually ask, tell us the definition of an electron volt. No, they'll just tell you change it from joules to electron volt. So which you have to know by heart is how can I change joules to electron volt? You should know that 1 electron volt is equal to 1.6 times 10 negative 19 joules, which you should do know it by heart. These are the things which you have to know it by heart. So when you know it by heart, if you find your answer, for example, if you find your answer in joules, you can easily turn it in what? An electron volt. Yeah, so that's how you go about it. Then, la formation du noyau de hélium s'accompagne d'une perte d'énergie de 28.35 mega electron volt. So this one basically, like they use for them to find, you should try using this formula. 1 unit mass atomic, 0 to 9.31, then you just try, you find it. You find that your answer will be 28.35 mega. It will be near 28.35 mega electron volt. Yeah, so that's the energy which was lost. So for you to change, so it's also possible to change from mega electron volt to what? To electron volt. So if you want to change to mega electron volt to electron volt, 1 mega electron volt is equal to 10 to the power 6 electron volts. So there's this secret which I can tell you. If you don't want to go through the pain of you know, sometimes we are human beings who forget. If you don't want to go through the pain of changing the mass of unit, the mass into kg, like if you want to find your energy which is lost, if you don't want to go through the pain of changing this unit mass atomic or into kg, the first thing which you can do is you just multiply it. You just use this formula, 1 UMA is equal to 931.5 mega electron volt. You find it in mega electron volt, which is 28 mega electron volt, 28.35 mega electron volt. After you have found your 28.35 mega electron volt, you can use this formula here. You know that 1 mega electron volt is equal to 10 to the power 6 electron volt. So what of 28.35 mega electron volt is equal to how many electron volt? So you find your answer. After finding your answer, you can finish by, if they want you to find in joules, you can finish by saying, I know that 1 electron volt is equal to 1.6 times 10 to the power 19 joules. So you just equate it. After equating it, you find your answer, the exact answer which you would find using the equation for Einstein. Yeah, if you don't want to go through the pain of changing to mass into kg, you can just go through that. Yeah, that's the secret, which if you know, we can use different roads, but you reach at the same destination. Yeah, that's what you can use. Yeah, so we have seen that, as I explained earlier, we have seen that the formation of the nucleus is followed by, if we're forming a nucleus, is followed by the loss of energy, and the investment, the inverse of it is also true. Investment, si on veut céder, it means break. Céder les noyaux de hydrogen en protons et neutrons. Il faut fournir une énergie de 28.35 megavolts. So if I want to break this noyon which I've formed the helium, so I've used it, I've lost 28.35 mega electron volts. That's the energy which I've lost when I was forming it. Now, if I want to break it, I must use the same energy to break that noyon. So that's why they're saying the energy for me, il faut fournir une énergie de 28.35 mega electron volts qui mesurait la ténacité avec laquelle les nucléons adhèrent les uns aux autres. Oui, so which measure the tenacity. Tenacity is the ability of something to be together. Which measure the tenacity of it being together. Which measure the tenacity of the nucleons being together one to another, like the nucleus combined in having a link together. So c'est la énergie du cohesion du noyau. I've talked about the energy, the cohesion du noyau, which is the energy, which is the noyau or the nucleus absorbed to break, to break into electrons and to break into protons and the neutrons. Yeah, that's all about default the mass. So when we talk about default the mass, just think about we are forming a noyon and the default the mass. This is something which the mass which is lost when we are forming a noyon. That's what you should put in mind. Then liaison energy and cohesion energy should just put in mind that this is the energy which liaison energy, the energy which is lost when you are forming this noyon. Then the cohesion energy, this is the energy which the noyon can absorb for it to go back to its state of being separate. That's all about the default the mass and the liaison du noyon. So something which is very, very interesting and very simple. So unit the mass atomic. You know that in an atom, the unit kg n'est pas adapté à la masse atomique. So in an atom, we don't usually use kg, the mass of kg. We use unit mass atomic. Why? Because an atom is very small, and it will be better if you use the SI unit or the SI unit of unit mass atomic. So this mass, so or utilize on unit particular unit the mass atomic. So what is unit the mass atomic? Unit mass atomic est égal par définition en 1/12 de la masse du isotope, the carbon, the atom, the carbon. So I explained earlier, why do we use carbon? Because carbon is something which gives us an average, which is a very good average because it has got the same number of protons and the same number of electrons, and we see that this carbon is the one which is very abundant, like the carbon 12, the isotope of carbon 12 is the one which is very abundant on Earth, rather than this other isotope like carbon 14, which is one you found in smaller quantities in what? When you are using carbon dating. So that's why I use carbon. So by definition, if they say define unit de masse atomique, unit de masse atomique est égal par définition en 1/12 de la masse de l'isotope. The isotope carbon the isotope de l'atome, the carbon. So this is the mass which is by definition. This is by definition. This is 1/12 the mass of the isotope of, this is 1/12 mass of the isotope of carbon 12. So we know that one unit mass atomic is equal to 1/12 de la masse de atom de carbon. So we know that 1 unit mass is equal to 1/12 de la masse d'une atom de carbon 12. So we're going to find here, we're going to find what of here we're going to find the mass of an atom of carbon. We know that n atoms of carbon, we know that according to what we did, if you remember what we did, we said one more the atom is equal to n atoms. We said that 1 mole of an atom is equal to n atoms, where n is the number of avocado. And we said that a mole, it measures the quantity of matter, and we defined like quantity of matter, like general quantity of matter, which is contained in the substance, general is the mass. So we can replace one more the atom by, if for example here we've got an atom of carbon. An atom of carbon, what quantity of matter does carbon contain? What is its mass in simpler term? Its mass is 12 grams. So that's what I'm saying. An atom of the carbon the carbon weighs 12 grams. What of one atom? One atom, what does one atom weigh? So we say 12 grams is equal to, I want you to hear me, attentively. 12 grams is equal to n atoms. Then x grams is equal to 1 atom. So we are looking for 1 atom. What of the mass of 1 atom? So 1 atom of carbon. So it will be 1, like if you equate, it will give you, if you try to equate, if you try to equate it, it will give you 12/n. If you just try writing it down, if you equate it, it will give you 12/n if you equate that equation. So when it gives you 12/n, now what should we do? So we want to equate here the main instance here, like the main instance we are doing all this. We want to equate unit mass atomic to grams, so that you'll be able to change unit mass atomic to grams. That's why we are doing here. So we see that 1 unit mass atomic is equal to 1/12 de la masse de la atom de carbon. So we have found that 1 mass of atom de carbon is equal to, it weighs, pensée or pensée means weighs. It weighs 12/n grams. So what usually happens is, here what will happen is, you see here, there's 1/12 times the mass atomic, the mass times what? Times the mass the atom, the carbon, which is 12/n. So it will be 12 cancels, which will give you 1/n. Then we have said n is what? Avogadro's constant. So Avogadro's constant, as we learned, is, I told you that you have to know this by heart. It's 6.023 times 10 to the power 23. Yeah, that's Avogadro's constant. So when you do your calculations, when you patch on your calculator, it will give you 1.666043 times 10 negative 24 grams, which is, if you turn it into kg, it will be 1.66 times 10 negative 27 kg. And we all know how to turn something into kg, right? We have got 1,000 grams is equal to 1 kg. Then we have got 1.666043 times 10 negative 24 grams is equal to x. And so so you say 1,000 grams is equal to 1 kg, then 1.66043 times 10 to the power negative 24 grams is equal to what? X. Then you equate it, then you find your x, then you find your kg, your kg, this will be your kg. So now, you will know how to find what? You will know how to, you know how to find the kg. You know how to change unit mass atomic to kg. So the formula which you have to put in by heart is 1 unit mass atomic. You have seen your questions. How come? 1 unit mass atomic is equal to 1 over n. So basically here, where there's 1, I want you to listen to me attentively. Yeah, if you equate it where there's 1 unit mass atomic is equal to 1 over n. N is a constant, which is always a constant, which is our Avogadro's constant, which you must know it per K. So you equate it 1 unit mass atomic is equal to 1 over n. Then that one we found 0. We found what? We found 0.03176 unit mass atomic. 0. So we say 0.033 unit mass atomic is equal to x. Then if you do your multiplication, you find that your x is equal to 0.031 unit mass atomic over Avogadro's constant. Then when you do your calculations, you find in grams first. After finding in grams, you divide by 1000 to change it to kg. Then after changing to kg, you can calculate your energy which was lost. Yeah, that's the way if you want. So unit mass atomic, mostly they use unit mass atomic. It mostly comes in hand if basically, most of the times the mass of an atom is given you unit mass atomic. If you want to change it to kg, yeah. For questions. Mr. Salosa, which calculations are you talking about for the questions?
I'm talking about the calculations that you've just done on the Avogadro's constant and above there.
Or the ones which I'm from explaining?
Yes, yes.
Okay. Then Mulenga Chewe. Which part do you want me to repeat?
The same part, the ones in red, the calculation.
Okay. So, yeah. So by definition, we say that here by definition, we say that 1 unit mass atomic is equal to 1 over 12 de la masse de atom de carbon. So, so now we want to find this mass of the atom, 1 atom of carbon. We want to find the mass of 1 atom of carbon. So we know that n atoms, like an atom of carbon, general, n atoms of carbon weighs 12 grams. So the weighing part is like n atoms of carbon weighs 12 grams. Since we have, from where we are coming from, like where we are from, like we said it earlier that 1 mole of an atom is equal to n atoms, and a mole of an atom is the quantity. This is like mole by definition. Mole, this is the SI unit for the quantity there, matière. Mole the atom, this is the quantity which is contained in n atoms. So my reasoning was, what is the quantity? What is the quantity of matter which is contained in a substance? Here, our substance is an atom, and our atom here is carbon. And we see that a quantity which is contained in a substance by definition is mass. Mass by definition, according to your secondary school, this is a quantity which is contained in a substance. So we see carbon. What is the mass of carbon? The mass of carbon is 12 grams. So we say this simply means that 12 grams of carbon is equal to n atoms. And 12 grams of carbon is equal to n atoms, and the x grams of atoms, which we don't know, which we are looking for, is equal to 1 atom. So this is, since we are dealing with 1 atom of carbon, I think there you got it. So when you do your equating, when you equate it, you find that you find the answer to be 12 over n. You have seen, 12 over n. This is the mass of 1 atom of carbon. You have seen, so you have found the mass of 1 atom of carbon. So you go to the first equation. 1 unit mass atomic is equal to 1 over 12 times the mass. The mass the atom, they simply means times the mass of the atom of carbon, which we have found to be 12 over n. Then you just simplify, you cancel 12, it will give you 1 over n. And I said n is always a constant, which is Avogadro's constant, which is 6.023 times 10 to the power 23. Yeah, that's the constant. Then after you find your answer, you find your answer in grams. Your answer must always be in grams. And after you find your answer in grams, you change it to kg. Then kg, we talked about how to change to kg, which is, which you have already talked about. 1000 grams is equal to 1 kg. You do your equating, then you find your answer. Yeah. So basically, here, what I was trying to tell you is, I wanted to find an equation or a formula which can equate unit mass atomic to Avogadro's to grams. So I found that this is, for you, you should only be interested in this. The 1 unit mass atomic is equal to 1 over n, where n is Avogadro's constant. That's where your interest should be. Then you calculate your default mass. After finding your default mass, let's say your default mass is 0.03 unit mass atomic. So 0.03 unit mass atomic is equal to x. You don't know the grams. Then you equate, you find that it will be 0.03 unit mass atomic over Avogadro's constant. Then you find your answer in grams, then you change it to kg. So basically you change it to kg because when you are calculating the energy loss, the mass, we have said the mass is always in kg. That's why the changing of kg comes in. Yeah, but if they have just told you to change it to unit mass atomic to grams, you can just leave it if they tell you to change. But if they tell you to find the energy, you have to change it to kg. Yeah. So due to time, that's where we end today. So today we talked about the Atomistique and the atomic structure, and I think by now you know what is an atom, what is the structure of an atom, all that. So next time when we meet, we'll start something which is very interesting. We'll start something which is, we'll talk now how this structure of an atom, we look more into an atom, you know, about shells, you know, about those. We talk something, how this structure came about. In secondary school, we only used to learn about we only used to know an atom has got three shells, it has got some shells, but we never really knew where it came from. So next time when we meet, we'll talk about 2 famous men who are Rutherford and Bohr, under theories classic. Yeah, we'll talk about them, how their views on an atom was, how their views on the structure of an atom was. So we'll look at it and we'll study it together. And you see, it's very interesting. It's very interesting actually. You'll see some mistakes which he made. You know, human beings make mistakes, and which Bohr he was able to work on those mistakes, and the Bohr also makes another mistake. So you see how this is all connecting. Yeah, so next time we'll start on structure electronic. There's atom theories classic and Ndwata. Yeah, if God allows, we'll do the whole topic because it's big, the topic. Yeah, so for today, I say thank you. That's where our lesson is ending. And have a nice day and enjoy the rest of your lessons. Yeah, I hope the things which I taught was just you heard it. Yeah, and feel free to ask me questions. Feel free to demand anything. We've got a group, and if you want, if you are shy to ask to the Chimie group, you can ask me questions. So I'll send you some questions which is only particular on those two things, like the things which you have learned today. I'll send you some questions, you do some questions. You don't even need to panic, like studying. No, like I know that you have understood and you just need to, what you need is not studying, but what you need is to pass through the things which I've taught you. So don't forget to pass through. And if you pass through, you have a higher knowledge of these things. Yeah. So for me, I say, thank you and have a blessed day.